All right, welcome. Okay, so this lesson is Unit 7, Day 2, Classifying Triangles. Let's go ahead and get started. The first part of this, so classifying triangles means we're going to give them names based on what they look like and some of their characteristics. Okay, so this first box says angles of a triangle. So triangles are named by the three angles, and angles can be named in two different ways. So here's an example. There's a triangle on the right and it's labeled ABC. Angle A can also be called angle CAB. So the angle A will always be in the center, angle CAB. Or it can be called angle BAC. Now you'll notice that whatever angle it is we're talking about, in this case we're talking about angle A, it's in the center of whatever we're listing. So the next one, if we wanted to figure out what angle B is right here, so we can call it angle ABC. Or we can call it angle CBA. The next one, angle C, can also be called angle ACB or angle BCA. Now, the sum of the three angles in a triangle, that means if you add them together, they will always be 180 degrees. So if we add the angles that are on the inside of the triangle, in this case it's 90 right here, these ones are probably 45, we don't really know. But if you add them together, you will get 180 degrees. So using information about the triangle, you can set up an equation to determine any missing angle measures. And we've been dealing with equations this entire year, so you should be pretty good at these. All right, so the next slide says side lengths of a triangle. So the side length of a triangle corresponds with the angle measure opposite the side. I get a lot of questions saying, what does correspond mean? And that's what I'm going to show you. Side AB, that's right here, corresponds with angle C. What that means is angle C, right here that I'm drawing in blue, angle C is what creates the line AB. If you make angle C shorter, if you were to shorten that angle, it would also shorten the line AB. Or like close that angle a little bit, it would shorten your line. So that's what it means, it corresponds. That means they go together, they go with each other. So side AB corresponds with angle C. The next one is side BC, that's right here, corresponds with which angle? We're going to take a look at the angle that creates angle BC, or has the chance to shorten the length BC, and that's this angle right here, angle A. If you were to make that angle smaller, maybe like this, that would all of a sudden shorten this side. So side length BC and angle A, they correspond with each other. And the last one, side CA corresponds with angle, let's take a look, here's CA, and so if you haven't caught on yet, it's just the angle that's opposite from it, just like right over there. So angle B. The smallest angle, let's take a look at where the smallest angle is. It says that the smallest angle will be opposite the smallest side. Here's angle A. It's smaller than angle B and angle C. And you'll notice there's the smallest side. So the smallest angle will be opposite the shortest side. And the largest angle will be opposite the largest side. This is probably the largest angle, and there's the longest side. Okay, so a side is congruent to another side if it has equal, sorry if you can't read that, if it has equal length. Keyword is equal. Congruent and equal kind of mean the same thing. All right, next slide. So triangles can be classified according to their side length and angle measure. Here's a couple examples really quick. All we're going to do is take a look at the side length of a triangle. So let me show you one right here. Now let's pretend all of those are the same length. I can't draw that perfectly, so I'm going to put these tick marks to show you, all right, all of these sides are the exact same length. That is called an equilateral triangle. And that means three sides are congruent or equal to each other. So we put this little equal sign with a little wave on the top. That means all three side lengths are congruent or equal to each other. The next type of triangle that you're going to see is an isosceles triangle. And on these triangles, they have two side lengths that are the same. And they also happen to have two angles that are the same. So I'm going to put two sides are congruent. All right, so maybe you've noticed a pattern. This one had three sides that were the same, equilateral. Isosceles have two sides that are the same. So scalene, it has zero sides that are the same, and it might look something like this. All side lengths are different. And I'm going to show that just by putting different markings on each of them. So I'm going to say zero sides are congruent or are the same. All right, angle measure for acute. We are moving on to angle measure. This means the inside of the triangle. So I'm going to draw a triangle that has acute angles. All of these angles are less than 90 degrees. Well, it's kind of hard to tell with that triangle. Let me draw a better one. All of these angles inside are less than 90 degrees. Actually, I'm going to say 3 acute angles. Okay, and then a right triangle is going to have 1 right angle right there. Now you'll notice that this triangle actually has acute angles over here, but it has 1 right angle, and therefore this triangle is a right triangle. Okay, and the last one is an obtuse angle, and all it has to have is 1 obtuse angle to be considered an obtuse triangle. An obtuse angle is greater than 90 degrees, and so I'm going to say that an obtuse triangle has 1 obtuse angle. That's all that it needs. And you'll notice it still has acute angles, but it has 1 obtuse triangle. 1 obtuse angle, which makes it an obtuse triangle. All right, this slide is extremely important. I would put a star by it if you have notes and you're filling out your notes or studying for your test. This slide is very important. It will also help you later on. All right, next slide. So match each of the images above to answer the questions about angle measure and side length. Which side corresponds to angle MNO? Well, like I said before, the angle we're talking about is just a letter that's in the middle. So which side corresponds to angle N? That means the side that is exactly opposite or goes along with angle N. Angle N helps create this line. That is MO. Side length MO. All right, next one. Which side corresponds to angle TUS? That's angle U. Let's find it. Just the side that's exactly opposite from angle U is side length ST. And so we put this little line above just to show that's the side length. Which side corresponds to angle VXW? So they're talking about angle X. Here's angle X. We're looking at the side length just directly across from it, or opposite, and that is side length VW. Which angle will be the smallest in triangle PQR? Okay, so now this one, I need to be able to figure out what angle Q is, because right now I'm not really sure what angle Q is. But what I do know is that there are 180 degrees in a triangle. And so you can say what plus what equals 180 degrees and fill in what we know. There's a couple different ways to do this. We do have 2 angle measurements, and now we just have to figure out what the third one is. Or you could say 180 subtract 77.2. Let's see what answer we get. 180 minus 77.2, and I get this answer right here. And then I still have to take away the next angle that I know, which is 41.4. And I get 61.4. That tells me that 61.4 is my third angle. I can double check this by adding all three of these up together. I can add 77.2 plus 41.4 plus 61.4, and it should equal 180. And if that's the case, then we did this correctly, and 61.4 will be the correct answer. So let's go ahead and put 61.4 degrees. Oh, that's not even the answer. We just figured out what the missing angle was. Now we can state the correct answer. The question was, which angle will be the smallest in triangle PQR? And the angle that's the smallest is angle P. So you could write angle P. If you wanted to list it a different way, you could say angle RPQ. Or you could say angle QPR. It doesn't really matter, as long as you have it in there, which angle is the smallest. All right, which one would be the largest? That's right here, because 77.2 degrees is the largest amount. So I'm just going to put angle R, or you could list out the other ways to list out angles. How can angle MON be classified? Let's go take a look at angle MON. When they're talking about classifying this triangle by its angles, we're saying what type of triangle is this? I see two acute angles, and I also see one right angle, and so this is going to be a right triangle based on its angles. Now, if we were classifying it by its side, this would probably be scaling, because all of the side lengths are different sizes. All right, next slide. So determine the missing angle in the triangles below. Find the measure of angle B, that's this one right here. And in order to do that, I'm just going to take 180 and I'm going to subtract the other angles that are already there, and it will give me my answer, which is 67 degrees. Number 3 says find the measure of angle F. This one could be tricky if you are not sure what the square means inside of the triangle. That means it's a right angle, which is exactly 90 degrees. So now that I know that, I can go ahead and solve this problem. I'm going to do 180, subtract my angles that I already know I have, and if I do that, I will get 45. I can always double check myself by saying 45 plus 90 plus 45 should equal 100, and if that's the case, then yes, 45 degrees is my answer. Now part 4 says find the measure of angle HIG. So HIG, they're talking about this angle right here, angle I. So same thing, let's take 180 degrees because that's what makes up a triangle, and let's start subtracting. And we will get 71 degrees if you do all your math. And if you don't trust me, go ahead and do it, because it's good practice for you. If you want to double check, you can add them up as well. 71 plus 58 plus 51 equals 180. So 71 degrees is your answer. Now on question 5, it says triangle JHL has angle HLJ, which measures 65 degrees, and angle LJH, which measures 50 degrees. Draw a sketch of triangle JHL and determine the missing angle and measure. Well, here's what I know. I need to draw a picture of a triangle. And I also need to draw some degrees in there. I have one of 65 degrees and the other angle is 50 degrees. So I'm going to say 65 degrees, 50 degrees. This picture definitely is not to scale, but I also don't care because I know that a triangle makes up 180 degrees, and all I have to do is subtract the degrees that I already have. And if I do that, I will get 65 degrees. So 65 would be my answer here. All right, next slide. Classify the triangles below based on side length and angle measure and find the missing angle. Okay, so this triangle right here is an equilateral triangle, and it looks like, because of these tick marks on the side, that all the side lengths are the exact same length. So that means we are going to call this an equilateral triangle based on its side lengths. That being said, the degrees are also the exact same degrees. So I could just do 180 divided by 3 angles, and it's going to give me 60 degrees. So each angle here is 60 degrees. And all of these angles are acute. Now number 7 says, oh, we should probably solve for x first. So let's take 180 and let's start subtracting the degrees that we do know. And it looks like it's going to equal 28 degrees because I have that here in my notes. So now that I know this angle measurement is 28 degrees, I can see here none of the angles are the same. That means none of my sides are the same either. All of these side lengths will be completely different lengths. So this triangle is called a scalene triangle. And I do have one angle measurement right here, which is 118 degrees. That is greater than 90. So this angle is an obtuse angle, which makes the triangle an obtuse triangle. Question number 8. I can see right off the bat that this is a right angle, and that means this is 90 degrees. So I'm going to call this a right triangle. And to get my angle, I'm going to take 180 and I'm going to subtract 90 degrees and then 57 degrees. And I'm going to get 33 degrees right here for x. And then if I were to classify this based on its side lengths, I can tell here that all of my side lengths are different because all of the angles are different. And so this triangle is going to be called a scalene triangle. All right, next slide. Constructing triangles. This is the triangle inequality theorem. Basically what this means is that when you have a triangle, I'm going to draw a picture here. Maybe that wasn't a good example. Your two smallest sides of your triangle, so let's say that this is 6 inches and this one is 5 inches. When you add those two together, the number you get, so I get 11, it has to be greater than the length of my third side. So let's just pretend I got 9 inches right here. This picture is not to scale. But what this theorem is saying is that my two shorter sides, when I add them together, so I get 11, that number has to be greater than the third side right here in order for my triangle to actually be a triangle. And so let's go ahead and fill this out. In order for a triangle to be formed, the sum of any two sides must be greater, well, I guess it can be any two sides, than the, I need to add then the length of the third side. So here's an example. Triangle ABC has side lengths of A is equal to 7 centimeters and B is equal to 9 centimeters. Number 1, the greatest C could be is, well, C has to be less than 9 and 7 added together. 2, the shortest C could be is, well, C would have to be greater than 9 and you would have to add 7 to C because you have to add your two sides together. And then for part 3, if we have C, it's going to have to be greater than 2 and it's going to have to be less than 16 because if you did 9 minus 7, you would get 2. And if you did 9 plus 7, you would get 16. So C has to be in between those two numbers. When 3 lengths meet the triangle inequality theorem, then one unique triangle will be formed. And if this doesn't make sense, I'm sorry, because this is kind of a harder concept to understand. So I wouldn't worry too much about this as long as you know that when you add two of your sides together, they need to be greater than the third side. Okay, next page. We are going to talk about, oh, it's loading a page, skip. Oh, that's really weird. Sorry about that. Okay, you know what, we're just going to end our notes here. I think that's enough to help you out with your homework though. If you have questions, please come and ask. The rest of the notes for this unit, you probably will not have to worry about too much.